10th important 5 marks in algebra. They are very important. These type of problems will exist definitely. So focus on these type of problems again. And three linear equations: a1x plus b1y plus c1z equal to d1, and a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. There are three linear equations given with three unknowns. Three equations with three unknowns x, y, z are given. Then how to solve these type of linear equations by elimination method? To solve this type of elimination method, first take it equations 1 and 2, 1, 2 and 3. Mark the equations, given equations are 1, 2 and 3. Now take any two equations, any of the two equations from the 3. Now for example, I am taking 1 and 2. Eliminate any one of the variable from these two equations. a1x plus b1y plus c1z equal to d1, and a2x plus b2y plus c2z equal to d2. Multiply the first equation by a2 and second equation by a1. We will get a1 a2 x, then b1 a2y, c1 a2z, and d1 a2. Similarly, multiply a1 by the second equation, we will get a1 a2, a1 b2, a1 c2z, a1 d2. Then the coefficients of x are equal now. The coefficients of x are equal now. We can eliminate these two equations. The variable present in x, we can eliminate the x in the first two equations. Now we will get the equation in terms of y and z. That is the equation in terms of y and z. Mark it as 4. There are three linear equations with three unknown are given. Take any two equations. I have taken 1 and 2. Eliminate a variable x in that. Then the resulting equation will be in y and z. The resulting equation will be in y and z. And then take any one equation from 1 and 2 and then with the three equations. The next process is choose any one equation from 1 and 2 with the third equation which is suitable to you. From first and second you can choose any one of the equations and then operate with the third equation. From the first two you can choose which is suitable to you. And then also solving 1 and 3 or 2 and 3. Solve 1 and 3 or 2 and 3. You can take any one. Either you can choose 1 and 3 or 2 and 3, because we have taken already 1 and 2. Now we can take 1 and 3 or 2 and 3. By use of these two equations, eliminate the same variable x. If possible, eliminate x. Eliminating x again, we will get one another equation in terms of y and z again. Let it be equation number 5. There are three equations given. First take any two suitable equations and eliminate x. Now I have taken first 1 and 2, I eliminated x, and then the resulting equation in y and z. Similar to that, take 1 and 3 or 2 and 3, anyone you can take. From that also you can eliminate x. Then we will get one another equation in terms of y and z. Let it be equation number 5. Now we have 5 equations here. Now 4 and 5 has only in terms of y and z. So solving 4 and 5, then solve 4 and 5. Solve equation 4 and 5. We can get either y or z according to the equation. It will form y and z. Solve 4 and 5 and then you will get the values of y and z. Substituting this y and z in the first three equations, any of the three equations, you will get the value of x. This is the process of finding solutions of three system of linear equations in three unknowns in your topic. Now, important problems in algebra for 10th standard. Given first question is solve 3x minus 2y plus z equal to 0. and 2x plus 3y minus z equal to 5 and x plus y plus z equal to 6. Solve means you should find the unknown values of x, y, z here. To find the x, y, z, we are using the equating coefficient method. First we should equate the coefficient, and then by using elimination method we can eliminate some of the certain, here there are three unknowns. We should eliminate any one of the unknown first by using elimination method. Now I am taking the coefficient of x here. Coefficient of x is 3. Now take the equation is 1, another one is 2, the third equation as 3. Here we have named the equations as 1, 2 and 3. Now look at the coefficient of equation 1 and 2. Coefficient of x of equation 1 and 2. Here we have 2, here we have 3 and here we have 2. And there, so multiply the first equation by the coefficient of the second equation coefficient of x 2. So which implies 1 into 2. Which implies here 6x, multiplying throughout by 2, 6x minus 4y plus 2z equal to 4, and then multiply the second equation by the coefficient of x with the first equation, that is 3 by 3. So 2 equation 2 into 3, which implies 6x plus 9y minus 3z equal to 15. Now look at here, the coefficient of both x are equal. We can subtract minus, minus, plus, minus. These two get cancelled. Now x eliminated. Remaining are minus 9, minus 4, minus 13y. Here plus 3 plus 2 plus 5 is there, equal to minus 15 plus 4, that is minus 11. Now name it as equation number 4. Already we have three equations here. This is equation number 4. Now take another two equations, 2 and 3. Now we have taken 1 and 2 here. Then take 2 and 3, eliminate the same variable x. For that, just multiply the third equation by 2, because here we have coefficient of x is 2, here coefficient of x is 1. So multiplying third equation by 2 will get third equation into 2 implies 2x plus 2y, 2x plus 2y plus 2z equal to 12. Then the second equation we have coefficient as 2. So second equation simply multiply by 1. That means the same equation present here. 2x plus 3y minus z equal to 5. Here they are equal now. So subtracting we have minus, minus, plus, minus. Here 2x, x eliminator. Now minus 3 plus 2 is minus 1y. Plus z plus 2 plus 3z equal to 12 minus 5 is 7. Name it as equation number 5. Now look at here, we have two equations 4 and 5. In this only two variables y and z appears. Just multiplying the fifth equation by 5 and fourth equation by 3, we can eliminate the value of z now. So here multiplying, there are two equations 4 and 5. Look at 4 and 5. Here coefficient of z is 5, here coefficient of z is 3. Or we can multiply the fifth equation by 13. We can equate the coefficient of y and then we can solve. Because of some big number, I can choose this one. If we choose fifth coefficient of y, to equate coefficient of y, just multiply fifth by 13, it is enough here. So now multiplying by 13. Now take 4 into 1. Multiply fourth equation by 1, there is no change in it. Minus 13y plus 5z equal to minus 11. And then multiply the fifth equation by 13, which implies 13 minus 13y plus 13 into 3, 39z equal to 7 into 13, 70, 21, that is equal to 91. Now they have equal sign, so we can subtract, change signs. These two get cancelled. Here 39 minus 39 plus 5 minus 34 is that equal to here 2 minus 102. Minus 102. Now divided by z, which implies z equal to minus 102 divided by 34, that is equal to, now multiply it by 3, we will get 102. which is equal to 3. So z equal to 3, we have got the value of z equal to 3. Now substituting z equal to 3 in the fifth equation, which implies, equation 5 implies, when substituting z equal to 3, minus 1y plus 3 into z value 3, 9 equal to 7. So minus 1y equal to 7 minus 9. So minus y equal to minus 2, which implies y equal to 2. So we have got two values. One is y equal to 2 and z equal to 3. Now substituting y equal to 2 and z equal to 3 in any one of the first three equations, I am choosing third equation because it is easy to calculate. So I am choosing the third one. Now substitute y equal to 2 and z equal to 3 in equation number 3. We'll get x plus y means 2 and z means 3 equal to 6. Substitute y and z in equation 3, we will get x is unknown. Y and z we have value 2 and 3. Substituting here 2 plus 3 equal to 6. So x plus 5 equal to 6. Adding these two values 5. Now x is equal to 6 minus 5 equal to 1. Therefore x is equal to 1. So here we have the values x is equal to 1, y equal to 2 and z equal to 3 are the solution. Therefore solution x comma y comma z equal to 1 comma 2 comma 3. Now substituting 1 2 3 in the equation, it should imply the right side value 2. Substitute here 3 minus 4 plus 3. 3 minus 4 plus 3 equal to 2. Similarly, you can substitute the values in the left side of the given equations. It will yield the right side equation. Then only your answer is correct. You can check yourself by substituting x, y, z in the above given three equations. All the three equations should satisfy all the three equations. The 1 2 3 the results of x, y, z should satisfy all the three given equations. Question number 2, solve x plus 2y minus z equal to 5 and x minus y plus z equal to minus 2. Minus 5x minus 4y plus z equal to minus 11 is given. So look at the equation 1 and 2. The coefficient of x are equal and the coefficient of z are equal, but they are in different sign. So just adding 1 and 2, we can eliminate the coefficient of z here. Look at here. Here we have minus z, here we have plus z. Just adding the two equations, we can eliminate the value of z. And then look at 2 and 3. Here we have z and here also we have z. Both of the equations 2 and 3, the coefficient of z is 1. By subtracting, we can eliminate the z value from 2 and 3. So now from 1 and 2, 1 plus 2 implies 1 is x plus 2y minus z equal to 5 and 2 is x minus y plus z equal to minus 2. Adding these two values, z eliminated. 2x minus y plus 2 is 1y equal to 3. Let it be equation number 4. Already we have three equations, 1, 2 and 3. Now it is 4. And then look at 2 and 3. Subtracting 2 and 3, we can eliminate z. So 2 minus 3 implies equation 2 is x minus y plus z equal to minus 2. And then third equation is minus 5x minus 4y plus z equal to minus 11. Now subtracting minus plus here plus z eliminated again. Here 6x, then plus 4 minus 1 plus 3y equal to 11 minus 2, here 9 plus 9. This is equation number 5. Look at these two equations here. When we multiply it by 3, we can get this equation. So now we should solve these equations, equation number 4 and 5. Now divide the fifth equation by 3. Equation 5 divided by 3 implies 2x plus 1y equal to 3. That is equation number 6. We can take it as, or equation number 5 here. Can apply equation number 5 here. After dividing, you can take it as equation number 5. Now listen carefully here. Equation 4 and 5 gives same values, 2x plus 1y equal to 3, 2x plus 1y equal to 3. So solving 4 and 5, 4 minus 5 implies 2x plus 1y equal to 3 and 2x plus 1y equal to 3. Subtracting we will get 0 equal to 0. Now here we have an identity 0 equal to 0. This means the system of equations has infinitely many number of solutions. This means the given system of equations has infinite number of solutions. Because when we multiply it by 3, we can get the fifth equation. So these type of equations are formed. These equations should have infinite number of solutions because these two lines are coincident lines. One on the another. These are known as coincident lines. When coincident lines occurs, this system has infinitely many solutions. Now one of the third 5 mark here. There are three equations again. 3x plus y minus 3z equal to 1. Minus 2x minus y plus 2z equal to 1. Minus x minus y plus z equal to 2. We should eliminate any of the variable first. For that I have chosen I am choosing 1 and 3. Here we have minus x, here we have plus 3x. So multiply it by 3, we can eliminate the value of x, or we can choose the first and second by adding y and y get cancelled. You can choose any of the way. So easily we can choose 1 and 2. Taking 1 and 2, just adding, the y is eliminated. The variable y is eliminated. So 1 plus 2 implies 3x plus y minus 3z equal to 1. And the second equation minus 2x minus y plus 2z equal to 1. Just adding, y eliminated. 3 minus 2 is 1x. And minus 3 plus 2 is minus 1z equal to 2. Let it be equation number 4. And then taking 2 and 3, just subtracting, we can eliminate y here. 2 minus 3 implies equation 2 minus 3 implies equation 2 is minus 2x minus y plus 2z equal to 1. And 3 is, I have written here, 3 minus x minus y plus z equal to 2. And we are eliminating y, so change its sign, plus plus minus minus, which implies here minus 2x plus x is 1x minus x. Here minus 1 y get cancel, minus plus. Here 2z minus z is 1z equal to minus 1. Now this is named as equation number 5. Here we have equation 4 and 5. Look at the left hand side of the equation 4 and 5. We have x minus z equal. Here also we have minus x plus z. Just adding the two equations, adding 4 and 5. 4 plus 5 implies 4 is x minus z equal to 2, and 5 is minus x plus z equal to minus 1. Adding the values, 0, x eliminated, z also eliminated, that is equal to 1. Now we have 0 equal to 1 here. So this is a contradiction. 0 is not equal to 1. Therefore, this type of system of equations is inconsistent. It has no solution. So this given system of equation is inconsistent. For here we have three equations. The two equations are in the ratios derived from the given ratio, and one more equation is here. By taking two equations from this ratio, first equating first two terms, x by 2 minus 1 equal to y by 6 plus 1, and equating next two ratios, y by 6 plus 1 equal to z by 7 plus 2, and here we have third equation, y by 3 plus z by 2 equal to 13. Equating first two terms and then equating next two terms, we can get two different equations. Now here x by 2 minus y by 6 is equal to 1 plus 1. Grouping the variables one side, constants the other side. X by 2 minus y by 6 is equal to 1 plus 1, 2. Now x by 2 minus y by 6, which is equal to 2, can take, which is equal to 2. Now cross multiply or multiply it by 6, we will get 6x by 2 minus 6y by 6 is equal to 2 into 6. Now these two get cancelled. 3x, here 1y equal to 12. So 3x minus 1y equal to 12 is the equation number 1. And here also grouping constants one side and variables on the left side. We have y by 6 minus z by 7 equal to 2 minus 1, which is equal to 1. Now taking LCM here, cross multiply 7y minus 6z by 42 equal to 1. Now cross multiplying 7y minus 6z equal to 42. Let it be equation number 2. And then the third equation, for the third equation here also they are prime numbers, cross multiply 2y plus 3z divided by 6 is equal to 13. And then cross multiplying 6, 2y plus 3z equal to 78. This is equation number 3. Now we should solve these three equations and we should find the values of x, y and z. I am writing the simplified equations here. They are, one is 3x minus y equal to 12. 3x minus y equal to 12. This is equation number 1, simplified equation here. 7y minus 6z equal to 42, equation number 2. And the third one is 2y plus 3z equal to 78. This is 3, third equation. Now look at the equation 2 and 3. Look at the equation number 2 and 3. Here we have minus 6z plus 3z. So multiplying the third equation by 2 will get 6z here. Multiplying by 2 will get 6z. Here we have minus 6z. We can eliminate z, can find the value of y. So multiplying the third equation by 2, 3 into 2 implies, third equation by 2, 4y plus 6z equal to, multiplying by 2, 140, 156. And then the second equation by 1, no change in it, 7y minus 6z equal to 42. Subtracting will get 6z cancel, 6z get cancelled, remaining 7 plus 4 11y equal to 8 9 1 198. Now y equal to 198 divided by 11 equal to 18. So 18 11s are 198. So y equal to 18. We have got the y value as 18. Substituting y equal to 18 in equation number 1. Substitute y equal to 18 in equation 1. We get 3x minus 18 equal to 12. And 3x equal to 12 plus 18, and 3x is equal to 30, which implies x is equal to 10. 30 by 3 equal to 10. And now substituting the value of y equal to 18 into 2, we'll get the value of z, or y equal to 18 into 3, we can get the value of z. So substitute y equal to 18 in equation number 3. We have 2 into 18 plus 3z equal to 78. Here 36 plus 3z equal to 78. Now 3z equal to 78 minus 36. Now subtracting 3z equal to 42. 3z equal to 42. Now z equal to 42 by 3, that is equal to 14. So z equal to 14. Now the values are, solution x, y, z equal to, x is equal to 10, y equal to, x is equal to 10, y equal to 18 and z equal to 14. Therefore the solution is 10 comma 18 comma 14. Next one is solve 1 by 2x 1 by 4y minus 1 by 3z equal to 1 by 4. 1 by x is equal to 1 by 3y. 1 by x minus 1 by 5y plus 4 by z equal to 2 into 2 by 15 given in mixed fraction 2 into 2 by 15. Here the variables unknowns x, y, z are in the denominator. For our convenience, we can substitute some of the variable to 1 by x, 1 by y, 1 by z. Then we will solve. It is easy to solve the solution. So 1 by 2x means it can split it into 1 by 2 into 1 by x. And 1 by 4y means 1 by 4 into 1 by y. And 1 by 3z mean 1 by 3 into 1 by z. Now I am taking this 1 by x as p and 1 by y as q and 1 by z as r. Or some other variables you can substitute, but except x, y and z. Now I am keeping 1 by x as p and 1 by y as q, 1 by z are r. Then it will change as p by 2. 1 by 2 into p or 1 by p by 2. It will be equal to 1 by 4 into q or q by 4. It will be equal to 1 by 3 into r or r by 3. So the first equation will turn as first of all you should write let 1 by x is equal to p and 1 by y equal to q, 1 by z equal to r. Equation 1 turn as the given equation turn as 1 by 2x p by 2 plus 1 by 4 into 1 by y, that 1 by y is q, so q by 4 in plus, sorry here minus is given, minus r by 3 equal to 1 by 4. And then taking LCM, which will be equal to, simplifying this, or you can complete the other equations, then we can go. Now similarly, the second equation is 1 by x is, 1 by x means it is p, so p equal to 1 by 3 into 1 by y, 1 by 3 into q, that is equal to p equal to q by 3. And then for the third one, 1 by x is p, minus 1 by 5y is minus q by 5 and 4 by z plus 4r equal to 2 into 22 by 2 into 2 by 15. Mixed fraction is given, so it will be equal to 15 into 30 plus 2, 32 by 15. 32 by 15. Look at here. Now cross multiply this 3 will get, which implies 3p equal to q. So 3p minus q equal to 0. Here we have formed one equation, either 3p equal to q or 3p minus q equal to 0. And here multiplying by 15 will get into 15. Multiply by 15. Here 15p minus 15 by 5, 3q, and then plus 15 into 4, 60r equal to 15 into 32 by 15, that is equal to 32. Here we have formed one equation, and this is the equation number 3. Here equation number 2 we have formed, and then the first equation will be from these 3. Here LCM is 2, 3, 4, 3, 12. Multiplying 12, the first one, multiplying it by 12 will get, multiplying by 12, 12p by 2 plus 12q by 4 minus 12r by 3 equal to 12 by 4. Here we can cancel it 6 times, here 3 times, and here 4 times, and here 3 times, which will be equal to 6 into P plus 3 into Q minus 4 into R equal to 3. This is the equation number 1. From this we have derived 6P plus 3Q minus 4R equal to 3. And from the second information we will get 3P equal to Q or 3P minus Q equal to 0. And from the third information, third equation, we will get 15P minus 3Q plus 60R equal to 32. If it is all divisible by 3, you can divide it by 3. Here 5, 1, all are divisible by 3, you can divide it and then you can write a equation. So equation 1 is 6P plus 3Q minus 4R equal to 3. That is equation number 1. And equation number 2 is 3P equal to Q. Let it be equation number 2. And the third equation is here writing this one here 15P minus 3Q plus 60R equal to 32. This is equation number 3. Now I found 3 equations. We should solve these 3 equations. We should find a value of P, Q and R now. To solve this, listen carefully here. Substitute 3P equal to Q here. And then in this equation also, the P is eliminated. The 2 equations will be formed in Q and R. So, substitute 3P equal to Q. 3P equal to Q or Q equal to 3P. Now 1 implies 6P, Q equal to 3P, so 3 into, next one plus 3 into, here we have 6P, plus 3 into, Q equal to 3P, 3 into 3P, minus 4R equal to 3. Simplifying this, 6P, this is 9P, 6 plus 9, 15P, minus 4R equal to 3. 15P minus 4R equal to 3. And now, substituting 3P equal to Q or Q equal to 3P in third equation, substitute Q equal to 3P in third equation. We will have, third equation implies 15P minus 3 into Q is 3P, 3P plus 60R equal to 32. 15P minus 9P plus 60R equal to 32. Simplify it again. 15 minus 9, we have 6P plus 60R equal to 32. So all are divisible by 2, you can divide it. So dividing by 2, 3P plus 30R equal to 16. And this is the equation number 5. Here is we have equation number 4 and this is taken as equation number 5. Look at 4 and 5. In these 2 equations we have only P and R. So solving 4 and 5 we can get P and R. So in that purpose, here we have 15, here we have 3. So multiplying the fifth equation by 5. So 5 into 5 multiplying fifth equation by 5, it will be 15P. Here we have 15P. So 15P plus 150R equal to 80. Multiplying fifth equation throughout by 5. And then keeping the fourth equation as it is. So 4 into 1 which is equal to 15P minus 4R equal to 3. Here we can subtract P eliminated. Now 150 plus 4, 154 equal to 77. Here R included. 154 R equal to 77. Which implies R equal to 77 by 154, that is equal to 1 by 2. Now we have found the value of r, that is equal to 1 by 2. Here r equal to, look at here, I am writing here, which implies r equal to 77 divided by 154, that is equal to 1 by 2. So r equal to 1 by 2. Now substituting r equal to 1 by 2 in 4 or 5, we will get the value of p. So substitute r equal to 1 by 2 in 4, will get 15p minus 4 into 1 by 2 equal to 3. Can cancel these 2 by 2. So 15p minus 2 equal to 3, which implies 15p equal to 3 plus 2, 5. This plus 2 on the right side, minus 2 on the right side, plus 2. 3 plus 2 will be equal to 5. Which implies p equal to 5 by 15, that is equal to 1 by 3. So now we have another value, we have found another value, p equal to 1 by 3. Now r equal to 1 by 2 and p equal to 1 by 3. Now substituting this r and p in any one of the equations, we need the value of q only. Substituting in the value of equation number 2, 3p equal to q, we will get the value of p immediately. So substituting in 2, substitute p equal to 1 by 3 in equation number 2. The equation number 2 is 3p equal to q, 3p equal to q. So 3 into p value is 1 by 3 equal to q. Can cancel these two, which implies q equal to 1. Q equal to 1. So the values of p, q, r are, now we found the values of p, q, r. So p equal to 1 by 3 and q equal to 1 and r equal to 1 by 2. Here we need the value of x, y, z. X is equal to, I am writing here the solution, x is equal to p equal to 1 by x, which implies x is equal to 1 by p, and q equal to 1 by y, which implies y equal to 1 by q, and r equal to 1 by z, which implies z equal to 1 by r. So reciprocaling p, q, r will get the values of x, y, z. The reciprocal of 1 by 3 is 3, so the value of x is equal to 3. The reciprocal of 1 is 1, the value of y is 1. The reciprocal of 1 by 2 is 2, so the value of z equal to 2. So the solution of x, y, z, solution for the given equation x, y, z equal to x is equal to 3, y equal to 1 and z equal to 2 are the solutions.